Alright, so far we've managed to parse the data structure from a PDF file, and that's basically being able to build the AST, sort of speak, of the PDF file. So we are able to parse booleans, numbers, strings, arrays, dictionaries, streams, and if you remember from last time, the PDF file has a structure. It's pretty simple. It has something called indirect objects, which are these indexed objs and then end with end obj. So these are indirect objects, and each such object has inside of it uh, a list of direct objects. And for example, it can have dictionaries, which look like this, streams, which are the things that we are mostly interested in. And I guess, dictionaries and streams are the stuff that we care about. So yeah, I finished off. I think I was supposed to, finish myself the parsing of arrays, I remember correctly, and strings, which I mean are, not that important, but just to have everything being parsed. And today we are gonna look into iterating all these objects, checking if we have a stream in that object, then checking if it's flat decode, and if it's flat decode, we just take out the text from the stream. And if it's for an image, we have DCT decode as the filter. So yeah, if we have DCT decode, then we just take this and save it as a JPEG. So hopefully that's gonna work for us. So yeah, let's see. So if I create a new tab, let's nix, yeah. And if we check this, you can see that so far I was just printing this as a demo, not that nothing crazy, to be honest. It's just, where is it, show stream. So when I parse a stream, I just try to display it. So yeah, unzip it and show I mean, that sounded a bit weird, but you know what I mean. Uncompress the stream and show the text inside of it. So yeah, let's try. I mean, we are not gonna do this one anymore. We'll have to do it from, I mean, we can just remove it. We'll have to do it from the main function. But first, yeah, let's take a look. So parse dictionary, we did that together. Then for parsing a string object, I was just looking for this less than symbol or parentheses, and yeah, we remove those, and then we take the string from inside. So yeah, I mean, if there are strings in the PDF file, so for example, I know there are some strings here at the bottom, like Philip, who made this PDF file, and also these things are strings. So the PDF parser is able to parse these, which is nice. The stream, I think this one we also did together, so it's not that interesting. Then the array parser is the same as a string, except that it uses square brackets. And instead of parsing just a string literally inside, we can parse multiple direct objects. So I don't know if arrays in PDF files must have the same type or something, but in my case, I don't really care. We just parse anything, like any object inside, so it is what it is. Name we also did together, I think. Pointer objects, yeah, same. And then number objects, and yeah, it's I know it's a bit scuffed. So like how I parse, I think numbers. I have this is number predicate, and yeah, the scuffed part is that I don't check if it starts with a minus. I just check if it's a minus or a dot. So you can have weird numbers in this format, but it's not really to use in production, it's just to learn and yeah, try to figure out how to use this PDF parsing stuff. So yeah, if I were to do it for production, I wouldn't just do, I would probably implement a Lexer from scratch and then the parser. So yeah, would take more time, but this is more fun, I would say. So yeah, parsing the number, we just check if it's int or float. The boolean, have no idea, I haven't seen a boolean yet in a PDF file, but if Wikipedia says you can have it, I said okay, why not. So yeah, that's pretty much all of the cases covered. So we have everything covered, yeah. So we should be able to parse anything basically. So here we complete the parsing, right? We parse indirect object, and after we parse all the indirect objects, yeah, sure, we also parse the xref, but we don't care about it. I guess the xref is just the layout of the PDF, but I don't think I care about it, so I ignore it. And after we parse the PDF, we have a PDF object inside of this PDF, which should have a list of object T's, I guess. But yeah, probably all of them are gonna be indirect objects. So yeah, if we go ahead and let's try to print some stuff. So for example, print f percentage d. Let's print the number of indirect objects that we have inside of PDF. Dot count. So let's see this result. So it says we have 25 objects in the PDF file, which I mean, makes sense. So now let's try to do a for loop. Objects count I plus plus, and let's have object T, which is the type that we want to extract, probably object. We can even make it like 0 just for the sake of it. Then dynamic array, dynamic get. Let's do here pdf.objects, then the index is gonna be I, and the item is gonna be a reference to this object. Okay, so this is how we do, I mean, it's just my library, ds.h plug, shameless plug, but yeah, it is what it is. Okay, so I would expect that, I mean, I won't do a switch because I expect that all objects are gonna be indirect objects, or at least the objects that I care about are gonna be indirect. So if object dot kind is equal to object indirect, then 1 second. So if it's an indirect object, it's gonna be exactly indirect object. Okay, so we can do something like printf %d. Oh, actually I don't it's dot object. Wow. So object number, well, so many objects, it feels like I'm doing Java. Generation number. Okay, so this thing should print some stuff. Only one? That's weird. Something feels not good. Yeah, this is weird. Maybe I forgot to set the kind. So parse PDF. Here we parse an indirect object. I feel like I forgot to set a type on the object. But this is just indirect object. So if we go here, we get back like indirect object. Oh, wait. This is not object, is indirect object. Yeah. Okay, then I didn't make an oopsie doopsie, it's just that this is just indirect object. So all of them are indirects. All right. So it's fine. This is the non static part of C that you can do void pointer and all of the static goes away. So yeah, I mean it's still static, but you can cast from a type to another type, and there's more of the the static type versus dynamically typed, and then we have weak and strong. So C is more like a weakly statically typed language, so that's why you can cast it from one type to the other, like it's because it's just memory bytes. So that's the thingy. So how can we check something interesting? Is stream is gonna be false, and then let's do int j is equal to 0, and we go from j to objects dot count. So we go through all the children of this indirect object, and if we are gonna encounter something like object t obj, let's do equals 0 ds dynamic array get objects, and we have to reference it, and then j, and here obj, and if obj dot kind is equal to stream, or like object stream, then we set is stream is equal to true, and we can break. So basically we found a stream object. I mean, it's a bit scuffed how I do it here, but it's in the main function, so I can do it. It's like, let's do it scuffed, and then I can refactor it, but let's just prove that it's gonna work. That sounds good to me. All right. I mean, I could also do something like well, now we know that it's a stream, so if is stream is equal to 1, then let's just print something for now. So yeah, we have these four which have streams inside of them. Now I mean, I was just thinking, like, probably I know this feels like the best way to do it. We check if it's a stream, and now we know that the first item is gonna be a dictionary and the second one is gonna be a stream. That's just how this PDF parser should work. I mean, that's how it should be. So let's not think too much. So we have a dictionary which is gonna be 0 for now, and then we can ds dynamic array get from objects. We take the first one into dictionary. We can even just assert that dictionary kind is equal to the object dictionary or something, object dictionary. That we can just assert that because I'm lazy to do it in a separate function. So then we have the stream from object.objects. We take the first one into a stream. All right, we again assert stream.kind is equal to object stream, and let's print that thing again. It works. So our assumption that we have a dictionary and then a stream works. Okay, now let's do the deflate. Well, for this one I'm gonna do an enum. So yeah, enum filter kind. So if we check on our thingy, we have flate decode. Flate decode. Let's do filter flate decode and filter. The other one is dct decode. Dct decode. Okay, I like it. Filter kind. So now let's do a function filter kind. Get filter kind. Let's say it's gonna take in object t dictionary. I mean, that's the best way to put it, I guess. I mean, could be this dynamic array dictionary, but I guess that at least forces that. So let's do it like that. And I could say, well, it has these items, so it's easier to reason about it. Okay. Filter kind is gonna be, what do they call it? Get filter kind. Yeah. Dictionary dot dictionary. I feel like that makes sense. And then we can do a switch kind. And now we have our play decode where we can just show stream I guess. And in here, yeah, I don't know. So let's just break. And for dct decode, we'll do like copy JPEG or something. But let's check this out here. For int I is equal to 0, I is less than dictionary count, I plus plus, right? We have to do something like object kv, it's equal to 0 just to initialize it, and then ds dynamic array get. From our dictionary we want to get kv, and the index is last year, and now it's second, so yeah, we get the kv thingy. So So now we can check if str compare. Oh shit, I don't remember if I kept. Let's printf the kv dot name. Let's do return one so we don't do anything. But, oh, perfect. So I don't keep the first thingy. That's perfect. If string compare kv dot name with filter is equal to 0, and here let's do a string and compare. I know these should be like constants, but yeah, it is what it is. So if that happens, we can assume it's gonna be a name. So let's do that. Right, like we can assert kv dot object. I mean, it's not good to assert it, but object name probably should be like a parser error or something. So yeah, but we can just assume that it's gonna be a name. Okay, so if kv dot object dot name, again string and compare, if it's equal to plate decode and it's 11 characters. If this one happens, then we return filter plate decode. Else if dct decode, this one is 9 characters. Just never do this kind of thing, like you have to create constants, and but yeah, I mean, for like a really small project, just a POC, you can actually do it if it's a POC, but once you start to refactor it, you have to think about stuff like that. Okay, and if I mean, I don't know what to return in case. Let's just do return play decode or something. I don't know. I mean, let's do return 2 just to make it crash or something. Okay, so if we now run this thing, we actually extract the text, so we show it. That's pretty neat. And next stuff is, let's try to do it on image, which won't do anything. Hopefully it's not gonna crash. Oh my god. Yikes, that fucking sucks. Yeah, I wasn't expecting it to do a true a while true loop. That's sad. Damn. Yeah, I mean, I was hoping that it's gonna work like first try, but I mean, anyway, maybe it's too big or something. Yeah, let's try to see where that can happen, like where does it go into that kind of loop. So let's have a printf or something here with just some text, so it gets here. Maybe it stays in this loop. Oops. Oopsie doopsie. Okay. So it goes twice through that one, which I mean could make sense because it's this stream and yeah, and then it's another object, but then maybe it gets stuck somehow on this big one. Yeah. Let's go into this indirect object and let's try to print percentage d for the object number and object, fuck my writing, object generation number. Oh shit. Zero zero. That's crazy. Huh. The fuck? That's indeed crazy. I mean, at least we got 2-0, which, I mean, decent. But huh, really strange. Really strange. Personally, I would print the slice, but I'm a bit afraid to do that. Print f %s %n slice.str or something. Let's see what we get now. So first it's gonna be I mean, actually I have no idea what it showed. Let's search for printf because oh, it's just that. Okay, perfect. So if I do something like, actually let's do it like this because it's gonna be easier to spot. So this is the first stream, which gives us 2-0. Then the next one is this one, which starts with 3-0. But I mean, it looks parsable. Why doesn't it parse it? Oh shit, yeah, because it's a new fucking okay. All right, so I guess skip comments, but also skip white space. How the fuck was I doing skip white spaces? I guess this thing. Okay. Nice. So maybe we need to also skip white spaces. Who knows? Yo, holy shit, it worked first try. I mean, almost first try if you ask me, but this is insane. Like it, I mean, and I'm not surprised that it works. Of course it works, like, but fail to uncompress data. And that's interesting. Like, sure, fail to uncompress data, it's fine. But show image stream dot stream and then break. Right, so show image and show stream. Let's take this function, let's put it here for show stream. But I mean, maybe the better name would be show text because it's text. And show image, it's a bit sad because we have to actually extract it. Show image what's funny is that we don't do any compression. What we actually have to do is just write the thing. So, but let's just printf something first. So we have one. That's the good news. So how can we ds write io write file? Yes, io read binary. Let's actually just copy this function and have something like write the binary file, writes the contents of a buffer into a binary file. To use on write, and I think I also want buffer len, the size of the buffer. I think it's important. Signed int buffer len, written or something. So let's do a write binary. So we just open the file in write binary, or we do std out. Okay, that makes complete sense. And then we should just do f write, so it says it's gonna do pointer size t and that. So we do buffer size of char buffer len file. And what does this return? I guess buffer size it returns. Buffer size. It's unsigned, so strange. We don't need SB. So we don't have to do anything there. We don't have to do anything here. Maybe just say result is equal to buffer size. I think that should do binary writing. So let's check. So file name image.jpg. We'll find a better name, but for now string.str stream.len. I think that should, okay. Let's remove the image just to make sure we don't get excited for nothing. So, oh shit, oh, no, where's the image? Oh, there's the image. It does work. Who doubted that it's not gonna? Oh shit. Actually, oh my god, but it's not an issue. It's just that I have my pause recording on minus, so I cannot unzoom it without pausing. But you know, I guess you'll see it straight up zoomed out. Yeah, I need to remember that though, just so I don't miss something. But yeah, so we actually get it. That's cool. Well, show text. how about, I mean, I'm probably gonna do something like we get the arguments, we have the image with the arguments, so that's gonna be taken from command line, the name of the file, and then here we're gonna pass in something like the uh, object generation number or whatever, like object number. So we have something like it's an ID of some artifact that we extracted, and then we save the text files as txt, and we do like image, or I guess the file name, underscore generation number or something .txt, and then for images we do the same thing. So that's how I plan to save them. So yeah, no, pretty cool for now. We actually are able to wait, kitty icat. Damn. Oh, so never saw this error from kitty. Like I thought, oh shit, I can display images, but yeah, whatever. But yeah, that's pretty cool. So here if we do sample PDF, right, we now get the text. So yeah, we are able to parse the text and images from PDF files, and yeah, it's nothing like hard-coded, but just the name of the file. So yeah, I want to get it as an argument and then be able to do this kind of stuff. So yeah, let's see. I mean, probably will try to do that on my own, and if you want to check that um, in the project, maybe we'll do something else next week. So yeah, we'll see, unless I find something interesting again with PDF files, and then we can continue. But yeah, I mean, that should be everything. We are able to extract text, we are able to extract images, so that's pretty decent result, I would say, for this week's PDF parser or whatnot. So see you guys next time.